Good morning. Who's still recovering from last night? No, I'm just kidding. I went to bed early. My name's Eric Schmidt. This talk is called Introducing Audience Insight. If you've been to some of the other media tracks or media sessions at Mix, you've probably seen this kind of new branding and consolidation around our media assets at Microsoft. And Audience Insight is a new member of this family. And today's talk is geared at getting you up to speed about what this new framework is, and then also getting your head around the problem space that we're targeting this framework. Also, this afternoon, Mark Sims from the SQL Server team is joining me. He'll be walking through part of this deck towards the end. So how many of you have seen Spaceballs, the movie? Okay. There's a part in the movie that is it's epic in terms of teaching you something very important around time-space continuum, and it's very important for this talk. So I'm going to go ahead and play this clip just to remind you of this concept. Do you remember Dark Helmet? There he is.
No, go past this part. In fact, never play this again. Try here. Stop. What the hell am I looking at? When does this happen in the movie?
Now. You're looking at now, sir. Everything that happens now is happening now.
What happened to then?
We passed then.
When?
Just now. We're at now.
Go back to then.
When?
Now.
Now?
Now.
I can't.
Why?
We missed it.
When?
Just now.
When will then be now?
Soon.
How soon?
Sir!
What?
We've identified their location.
Where?
It's the moon of Vega. Good work. Set a course and prepare for our arrival.
When?
1900 hours, sir. By high noon tomorrow, they will be our prisoners.
Oh!
How many of you have ever launched the website and had thousands of users out there and stuff started breaking and you didn't know what was happening to them? Or how many of you have tried to ask that question, what is happening now with the applications that I've built? This is one of the most difficult problems on the web, and ironically, most people don't try to address this problem in the right way. We try to build systems to give us log files, and we schlep through those log files, we look at W3C logs, et cetera, but we're always challenged with this problem of what's really happening now with my system. And as your systems start to get bigger and more complex, it becomes more difficult to understand what is happening now. The other thing that's difficult is to understand correlations, specifically if something happened in your application that related to something else. Trying to understand the relationships between those two things is also very difficult. So what we're going to talk about today is getting a better grasp on what is happening inside of your media applications, how to understand what's happening now, and also try to understand what just happened and why it happened. Audience Insight is a member of the media platform components. You see it down at the bottom. The implementation that we're going to show today, one of the pieces is a plugin for the Microsoft Media Platform Player Framework. And we just had a session on that delivered by our folks from Vertigo. So what is Audience Insight? It's really two things. One, it's a mechanism to provide low latency KPI visibility for your online media experiences. We used to talk about this saying real time. Real time implies now, right now. When was that? You just missed it, right? It was 2 seconds ago. So low latency in the terms of this talk, we're talking anywhere from kind of 1 second to a minute, and we'll get into kind of how that latency differs inside of the application. But for this talk, low latency is anywhere between a second to around 60 seconds. KPIs, these are things that are meaningful in your application. Who's doing what are they doing, how long have they been doing it, what thresholds have you hit, et cetera. The goal for these low latency KPIs is to enable you to react proactively and with precision. Most of the time, whenever something goes wrong or you're trying to make a business decision on data, you're doing it after the fact. You may be looking at Google Analytics 6 hours in delay, or you may be looking at Omniture 3 days in delay. Typically, by that point, the decision that you want to make is moot because you missed the opportunity. Or you may not have enough data to act with the precision that you want. The other piece of goal for Audience Insight is to enable you to extend the query and data model that you build around this implementation to meet your specific requirements. The idea here is that your business is constantly changing. You want to add new KPIs. You may want to even add a new KPI on the fly. This framework provides you the mechanism to do that. Another goal of this framework is this concept of real-time shaping. With media applications, web applications, you can get tons of data around behavioral patterns, usage patterns, et cetera. But typically what happens is you have a lot of noise, and you want to distill that down to one particular aggregation or one particular set of events. And instead of doing that kind of post-processing through log file processing or through relational processing, we're going to do that in real time. We're going to shape the data in real time to give you the exact information that you want. So that's how we kind of are focusing around this low latency area. And then the other piece of it is, well physically, what is it? What is Audience Insight? It's a SaaS-oriented or SaaS-focused framework. It's a set of components. We're going to walk through what these components are to enable you to create or extend business models. So if you're in the kind of media delivery space, you may want to build a new implementation on top of Audience Insight to provide your customers. If you work with large media publishers, you may want to go build a particular implementation of Audience Insight to get a better handle around the content that you're delivering. We're also focusing the framework from a SaaS perspective to leverage the cloud in order to manage volatility. The applications that we're going to talk about today could scale from a couple hundred users up to a couple 100,000 users. And in order to scale the implementation, we're going to leverage cloud infrastructure. And the last piece of it is we're targeting this to be open source, just like the rest of our media frameworks, like the RCE, our Rough Cut Editor, the Silverlight Media Framework. Because we believe at the end of the day, you want to get your hands on this, you want to extend it, and we want to help you do that. Kind of already talked about this, who should target Audience Insight. It kind of falls into a couple different buckets. So if you're a developer, ISV, or ASP that you want to enable this type of infrastructure, this is for you. If you don't necessarily fit into this category, you will pick up other pieces of how you could apply the same framework to other scenarios. Maybe if you're a games developer, you could take Audience Insight and drop it into a gaming application. We're not necessarily tied to just delivering video and media. You could even drop it inside of a line of business application. The other piece of this is why would you look at this? Because there are implementations that provide certain behaviors on the market. So I mentioned things like Omniture, Conviva, who provides a fantastic product in the marketplace. What we're doing with Audience Insight is we're focused on filling in some gaps. One, we want to enable developers to build solutions in order to customize the type of application that they want. They may augment an existing solution with Audience Insight. And we also want to help people understand the economic model of what it really takes to build an implementation like this. And this last piece is probably, the last bullet is probably the most important, because most people basically just say, I'm going to do without this real-time telemetry and these real-time KPIs and kind of hope that the rest of my systems are going to do the right thing. And if they fail, I'm going to go back and figure out what happened. Because the economic models and scale of what you have to build a system like this, today the barrier of entries are quite high. We're attempting to remove them. All right, So let's go back to these KPIs. This is some really interesting questions. So with Audience Insight, we're talking about video, we're talking about media. You can start asking questions and getting KPIs back for things like, what are my viewers watching? What type of quality are they receiving? Where are they located? How long have they been watching? And then you start to get into more business-specific questions like, how many mid-roll ads did I serve in the last 3 minutes? This is an interesting one. My team worked on the Olympics, the past Vancouver as well as the Beijing Olympics. During certain events, we were able to look in real time with another system and understand how many ads we were serving in near real time in order to shift ad delivery across sports. Curling was starting to blow up. We had way more users there, so we were dropping more ad pods in that particular sport. Curling got boring. We went back to downhill skiing. We were able to shift our ad delivery back and forth. But without that information, we're guessing, or we're making decisions too late. Then you get into even more specific things, starting to tie in correlation with social interaction. How many viewers from a particular region were watching a particular video tweeted in the last 5 minutes? Yesterday during the keynote and the day before, constantly looking at, hey, what's going on with Twitter traffic as it correlates to who's on stage, what demos are happening. Being able to correlate those two things is amazingly powerful. We didn't do this, but it would be kind of fun if we actually had like a shock belt for the speaker up there to let them know, like, hey, people think that you're not doing too well right now, right? Or get this guy off stage. The only way you can really do that is that they have the ability to correlate this information in real time. And then you get into like more low-level diagnostics information, like what percentage of viewers connected to my CDN in a particular region are experiencing certain types of buffering. Whenever you're delivering large volumes of content to large numbers of people, if you have people in buffering state, they're typically going to go away. And whenever they go away, you're going to lose money. So being able to answer these types of questions in real time actually can help you save or make more money. I've already talked about this. So I'm going to talk a little bit more about quality driving viewing time. But there are lots of studies around directly correlating quality to viewing time. Our kind of thumb that we put out in the marketplace is if users are experiencing any more than 2% buffering in their overall in their viewing episode, they're traditionally going to drop off about 1% for every percent that they go up. So if you get buffering into 8 or 9% ratio, you're going to lose a considerable part of your audience. We already talked about this ad piece, being able to drive higher CPMs, doing targeting. All right. So we set up kind of what KPIs are, and then also talked a little bit about the SaaS implementation. I want to dig into the 3 parts of Audience Insight. Audience Insight is really 3 things. There's a client aspect, there's a service aspect, and a visualization aspect. On the client, what we're going to walk through today is it's an SDK. It's specifically a plugin for the Silverlight Media Framework. We provide a standard set of filters, which then drive KPIs. And then we also provide this concept of a monitoring and a configurable remoting engine. Basically, we're providing everything that you need on the client side in order to make this solution work. On the service, there's 2 pieces to the service. We have this concept of a collection agent. So this collection agent is going to be collecting information from clients that are instrumented. That collection agent has some capabilities to it that are important for these types of scenarios. One of them is geotagging. So as messages come in, we're geotagging all that information in real time. So we can do geo roll-ups on the back end. We're doing real-time auditing. So you can go back and do replay of data. And we also have this concept of a scalable in-memory queue. So as your traffic or demand grows for this solution, we have a way to buffer data and make sure that we don't add too much latency or tip over the entire system. So that's this edge process. And then we have this concept of a Stream Insight implementation. How many of you have heard of Stream Insight? All right, so the two guys that worked on the project know what Stream Insight are. That's good. This is probably one of the most valuable things maybe that you'll get out of this talk is understanding what Stream Insight is. Stream Insight, and I'll talk about in a second, is a feature that ships with SQL Server. We are leveraging Stream Insight to process data that's coming from clients throwing through the edge to do these real-time queries in order to generate real-time KPIs. And what we've done is provided you, or we're going to provide you a reference implementation. Actually, Mark has done a lot of this work to help bootstrap you into a solution versus you having to write the code yourself. And the last piece of this, which is most important, is actually visualizing the data. So we've worked with SoftSource, a partner of ours out of in Portland, to help us build what would be a very utilitarian live rendering engine that understands the data that's coming from Stream Insight and understands the KPIs. And we're going to get into kind of what this visualization technology does versus other visualization technology that Microsoft ships. Okay, so now what we're going to do is a real quick Stream Insight deep dive, because if you don't understand what Stream Insight is, you won't understand the rest of the implementation. Stream Insight is a CEP engine, a complex event processing engine. It ships with SQL Server 2008 R2. The idea here is that you can throw a large amount of data at Stream Insight, and it can keep up with it in real time. So when we're talking large, what we're modeling right now around 100 to... Yeah, so we can process around 100 to 150,000 events a second against this implementation. What it's doing underneath the covers is actually querying these events, aggregating them, and then outputting the KPI data in real time. How it actually works is it's event response. It's not query response. So typically, whenever we're thinking about SQL Server, everyone thinks about relational tables. Data goes in. I'm going to write a query. It's going to aggregate it for me and hopefully output the right data that I want. Stream Insight is the complete opposite. It's event-driven. An event comes in, and then data comes out. Event comes in, data comes out. The queries that are doing this processing, they're always running. They're sitting there waiting for data to come in. And then as new data comes in, new data will flow out. And it's also non-transactional. So as events come in, they're processed and then dropped on the floor. So this is a logical implementation of kind of how Stream Insight works, and this is pretty much physically what we've built. We've built a client implementation, which is our event source. We're going to flow data through input adapters. We have queries for you. We then built an output adapter, which then shoves data into a SQL implementation, and then we have a way to visualize that data. One of the key things to understand with Stream Insight is out of the box is you're going to be, without a reference implementation, you're going to be challenged with a couple pieces. One, you're going to have to go build an input adapter. So for our implementation, we have an input adapter that's reading data on TCP. So it's going to flow messages from our edge servers to this input adapter. And as data flows into that input adapter, they're going to be converted into events. So I'm going to get a log message from a client. It's going to flow down and get turned into an event. That event is going to then be passed to a query. The query is then going to potentially subgroup that information, and you're going to see an example of this in a second. And then we're going to aggregate information kind of based on time. So how many events happened, what types of events, and then we're eventually going to then pass that information to an output adapter, which is going to record the data. So this is some code this is real code. This is running live now in the implementation that we have. We were working on the keynote and the Channel 9 broadcast the past 2 days. And one of the things that we were monitoring is video quality. What type of quality were all of our viewers receiving at a particular time? We were monitoring this by country and then also by the edge server that they were connected to. So if I'm in France and I'm watching the mixed keynote, where am I actually receiving that data from? So you walk through a standard link query in order to extract this information from Stream Insight. So the first thing I'm going to do is I'm going to read from the stream, and I'm looking at a video quality stream. I'm going to show you what a video quality message looks like in a minute. If I subscribe to that video quality stream, I can go ahead and process this query against it. The first thing I want to do is I'm going to group by application. So I have my Silverlight application, the mix one. I'm going to group by country and group by edge server. And then the next thing I'm going to do is start to kind of group or quantize this information into some type of time window. So going back to Spaceballs is, well, when is this happening? Well, it happened right now, but it actually happened in some type of time segment. It happened in the current minute. By default, our time windows are 30-second windows. You'll see this whenever we get into the visualization. So the next thing I'm going to do is I'm going to start grabbing information off of my particular event. I'm going to do some calculation. So here, this is the calculation I'm going to do for average percent buffering. So I want to average across all my users, everyone that's sitting in this window at a given time. There may be 150,000 events sitting in this window at one particular minute. I'm going to group them. I'm also going to look at some other things like how many HTTP errors they had, what average bit rate they were watching, and then finally down here, I'm going to calculate my concurrent viewers. So this snapshot in a given 30-second window is going to provide me the aggregation of all the data that's flowing through the system at that particular point in time, meaning the segment of time we're looking at. What happens on the back end, and this is some of the other magic that actually Mark wrote, is that same link query that is querying the stream will also output the appropriate SQL schema for you. So in this case, whenever you fire up our Audience Insight implementation, we'll go ahead and create the output database for you. The output adapter will then go ahead and push the output KPI from a particular query into the appropriate table. So here you can kind of see this query is creating this data against this SQL schema. And you can see things down at the bottom that kind of quantized into time. We have start time and end time, edge server name, total HTTP errors. Okay, so now what I want to do is actually get into some code and show you how you wire this thing up, how it works. The first thing I'm going to do is walk through the client. And in this diagram, what I've done is I've started to show you kind of what low latency means for this particular implementation. On the client, whenever we get into the code, we're batching things in 30-second intervals. So if an event happens, we may have up to, like from 0 or close to 0, up to 30 seconds worth of latency on the client. And then we're going to throw those messages at our edge service. Depending on what's going on with scale, it may take 1 to 2 seconds for us to then turn around, audit, geotag, and then push that on the Stream Insight. Then inside of the Stream Insight implementation, we're sitting there and we have these windows that events are flowing through. Those windows are in 30-second increments. So kind of depending on the flow of data, you may be within, say, 1 to 2 seconds, potentially up to, what is that, 62 seconds of latency, which is pretty darn good whenever you start to get into having 200 to 250,000 people using your application at the same time, and you want to ask the question, what happened right now? So the client architecture for Audience Insight, it's built against the Silverlight Media Framework. All the boxes in blue, this area, these are all pieces that are shipped today with SMF 2.5. You'll notice maybe some things, if you used SMF in the past, you'll notice some things that are involved in this implementation that you probably didn't touch before, in particular, this diagnostics and monitoring namespace. So the idea here is we're going to be monitoring the video playback inside of SMF. The highest kind of level that you program against the player is basically the player API. That player API, though, sits on top of something called the smooth streaming media element. And what we're doing is we're monitoring that smooth streaming media element with a diagnostics framework. So it's understanding, what type of frame rate am I having? Am I getting HTTP errors? What's my bit rate, et cetera? And then it is then turning on and throwing that up to this monitoring implementation. And it has some higher level logic in there in order to understand how do I group particular information, how do I average data out, and then it's going to throw information to the Silverlight Media Framework logging implementation. That exists today. And you could actually go build Audience Insight or something else like that on top of what exists today in SMF. What we've done is we've taken this one step further, and we are going to ship this Microsoft Audience Insight DLL, which then does things like batching and remoting to different types of services. So you may want to target a WCF endpoint or a REST endpoint. And then we also provide you the ability to kind of control configuration around what types of information you want to actually remote from your clients. So these are some of the references that you'll need to play with. And what I'm going to do is I'm going to jump over to my laptop, hopefully. And I'm going to show you how this works. Okay. How many of you have played with SMF in the past? Okay, just a couple. What I have here is a very simple SMF project that I created. So with SMF, we have the ability to, I'm not going to create a new one, but just show you, if I come into Silverlight, you can create a new SMF progressive or SMF smooth streaming application. We set up all the infrastructure that you need in order to get going as quickly as possible. So I have a smooth streaming implementation that I want to drop Audience Insight into. I've added the references that we talked about. So here's our Audience Insight. We also have logging and monitoring. We're pretty much ready to go. What we've done is we've, in essence, templatized all the information that you'd want the Audience Insight client to intercept that's flowing through your application. So we talked about video quality before. This is, in essence, the template that Audience Insight will use in order to pull information flowing inside the client, batch it up, and then send it off to our service. In order to make this work, all we had to do is drop that logging config into our project, and we're pretty much done, other than doing something like, well, I want to set up a new video item in order to play back. In this demo, I'm also going to show you this concept of the actual logging service that's running. This is what you get with SMF out of the box. As it's getting logs, we're going to intercept them, and you're going to see them. And then you're going to see, as logs are passed off to Audience Insight, you're going to start seeing batches flowing out. So we're subscribing to different events on top of Audience Insight here. So I'm going to subscribe to batch sending, batch, hopefully we don't have any batch failures, and then batch send success. All right, so let's go ahead and run this. It's Big Buck Bunny. Sorry, it's the hello world of video applications. So, all right, so there's Big Buck Bunny. He just started. What you see on the side is this is the application. It started. We loaded. And then we immediately sent a batch. What did we send? Well, we sent a batch that said application session start. So you can imagine if you have tens of thousands or hundreds of thousands of these messages, they're all going, and Stream Insight, in a given 30-second window, we can ask it, hey, how many application starts just happened? So that's pretty much it. I mean, to get going, all you have to do is drop that login config, set the references, and you're off to the races on the client side. Now, I'm going to give you a sneak peek, but we're not going to dive into this. This is what's going on in the back end. This visualizer is sitting there and looking at what's happening with this data flowing through Stream Insight, but I don't want to dig into that right now because that's the fun part. Go ahead and stop him. You'll see now, once we're off to the races and this video is playing, one of the default implementations inside of Audience Insight is every 30 seconds we are aggregating video quality. So I'm looking at things like frames per second, how many DVR actions there were, what's my audio and video download latency, a bunch of rich information that's constantly getting pulsed through video quality. Okay. All right. Out of the box, these are the log templates that we're going to provide. Application starts. We're very heavy focused on the video piece, so video loaded, video started, video quality. We have this concept of monitoring chunk download errors. So for smooth streaming, where we're actually rendering chunks from a CDN, it's very important to understand, well, if you have a missing chunk and you try to download it, it's bad for video quality. So sometimes that may be caused by a bad encode. So maybe you had Alex Zambelli do some high-end encoding for you, and he happened to be in a bad mood that day. You can actually see the manifestation of a bad encode with missing chunks. We actually had this happen at the PDC. So during the PDC, we had a couple of encodes for live streams with lots of missing chunks. You're watching the video, and then the next thing you know, it goes into buffering state, and you're like, what just happened? Well, it turned out that the encoder, the live encoder, had tipped over, and this is one of the ways to diagnose that problem. Then we get into some other application-specific things, like are people using full screen? Are they using closed captioning? Or you can extend it with your own custom templates. And that's what I'm going to do here, is extend this implementation with a custom template. So I already showed you this whole idea of I add an item to a playlist, it loads, it starts, I have video quality. So let's go back over to here. And I am going to run an ad. So great, we're showing Big Buck Bunny, but we're not making any money. I want to run an interstitial inside of this video. And as soon as I run that interstitial ad, I want to go ahead and generate a new log called, I think we call it ad rendered, so I can start calculating them in real time. Now, I may be sitting in front of my my DoubleClick console or something else where I'm actually managing my ad inventory, but I have another view of this, which is near real time, that's telling me very specific information. Again, in this case, how many ads are getting rendered against Big Buck Bunny. So I have a helper function called schedule ad, and we'll pass the video to it. Let's go look what that looks like. So schedule ad is pretty simple. Thanks to the beauty of our media framework, we made it as easy as possible for you. I'm going to create a new advertisement. I'm going to give it a URI. I'm going to tell it when I want it to start, and then how long I want it to run, and then I just go ahead and add it to the video that I want to play. Then the next thing I want to do is I'm going to say, what's my player name here? Sample player dot advertisement process changed equals this. So what I'm doing here is I'm going to subscribe to when that ad was started, and whenever that ad is started, I'm going to create a new log, now part of the Audience Insight framework. I'm going to create a new log. I'm going to call it ad delivered, and I'm just going to send it off to my log dispatcher. It's going to package it up and send it off to Stream Insight. So if you're paying attention, one of the things you have to do is make sure that you have a template. So there's the template. I intentionally made this template very simple. The template, all it's tracking is what's the timestamp that this happened at. I could do things like correlate it to the video. I could correlate it to the duration that actually occurred inside of my video session. There's all different types of things I could do to extend. So let's go ahead and run and see if this works. So session start. There's the counter. We're going to start this at the 10-second mark. Pay me some money. There it is, my lovely horses. There it goes. And then in about probably 10 seconds or so here, we're going to send another batch, and you're going to see ad rendered in our batches. There you go, batch sending. There it is, ad delivered. There's the tick or the timestamp on it. That's the actual message as well for the clip itself. So we played another clip. We played that ad clip, and then we had a video quality message in there. Now, if I go over to a different rendering implementation of this, we're also providing an OData feed in addition to this visualizer that I talked about, and we'll get into more in a minute. So we have a whole set of OData feeds that sit on top of these KPIs. This is a magical tool called Power Pivot that you can subscribe to OData feeds and then easily refresh them and do charting. So I'm going to go ahead and hit refresh. This feed is looking at the ad deliveries KPI, and we should see another row pop up here, please. Oh, there's actually 5 of them because I was doing some testing. So that's the 5th one. So this is the one that just came in. Now, obviously, if I was outside of my sliding window there or outside of my batch window, sometimes you hit refresh and it's not there. But this tool isn't the best tool to do things like sit there and refresh. What you'd end up doing is going back over to this magical tool and look at what's happening in real time. All right. Let me shut down him. I'm going to skip past this last piece, this concept of using additional data. You can also kind of prime Audience Insight with additional data to give it some hints about maybe if you're in a multicam situation, you can tell it, I want you to track events coming from the main player, from PIP, or only from one or the other. Or you can add just additional data that's specific to your application. All right. So some other pieces with this client SDK, and then we're going to get into the Stream Insight piece, is it's a bunch of stuff that you don't have to write yourself. So we wrote this concept of log templates and validation. We give you the ability to target WCF or REST implementations. We implemented a GSIP compression for you, so you don't have to do that. We can send large amounts of data, fairly large batches from the client with pretty tight file size on the wire. We also do response processing, so we have this ability to process responses from the server in order to control the client's behavior. And then we have this whole idea of queue throttling, meaning we understand how to prevent stampeding of messages so that if you have hundreds of thousands of clients out there, how to control batching and make sure that we're not pushing too much information to the server at the same time. And the last piece of this, which is probably most important, is we have this concept of an open wire format. If you don't like the format that we built and you want to build something else, go ahead and rip and replace it. The next piece is this edge collection service. I'm not really going to get into this because it's just code that runs. You drop it on top of an Azure web role. We target it at a large size, which is basically a 4-proc box. It's scalable, evenly scalable to around 35,000 requests a second, and it does the things that we talked about before. IP to geo resolution, low latency auditing, and then it understands how to optimize, how to send data in an optimized TCP manner off to Stream Insight. So you basically get this out of the box. You can go write it yourself. We've already done it. We spent about 18 months getting it what we think is right, so it's yours. The next piece of this, and Mark's going to take over here in a second, is this concept of the Stream Insight implementation. For the work that we're doing now, we're running it on an Azure VM, an extra large instance, which is 8 procs with 16 gigs of RAM. And they can process around 120,000 events a second, depending on the number of queries that you have. And again, we have this optimized TCP receiver. We have this idea of query templates that are then going to automatically create the SQL output for you so you don't have to do that work. So what we're going to do now, I'm going to have Mark step over, and we're going to walk you through kind of what it looks like to be a query on the back end of Stream Insight, because now that you see events throwing through the client, it's kind of the mystery about, well, what happens on the back end in order to produce these KPIs. So you are on E.
On E?
Yeah.
Up.
Yeah.
All right. So far we've gone through where does all the data come from, what can I do with it along the way, how do I make sense and reason over it. So as opposed to a traditional sense, in terms of more of a SQL-ish or a relational processing framework, what we don't do is we don't take the data, park it somewhere, then come back after the fact. That's great, it's very effective, very scalable, but has serious latency concerns. So instead what we do, as Eric was saying, is we intercept the data in flight, observe it as it flows through the system, and reason over it. So as the data comes in, we look at it and go, okay, what kind of log event was that was emitted from the server? Was it a video quality event? Was it an ad event? And what are the interesting questions about that given type of event? So we've been spending a lot of time talking about video quality. So let me just go into a quick flick from a code level, and then at a runtime level, what does an interesting question about a given type of message look like? So we threw together a quick little thing around how do we count up ads. You'll note that we're running about 12 to 15, depending on the implementation, concurrent simultaneous queries against data coming in, and they all look exactly the same. This is an example of how we calculated that ad metric, how many ads are showing up in a given time window. Same kind of thing. We say, all right, I have a query. I want to look at this stream of ads. I want to take the stream of ads and I'm going to group it by the application. So we have stream implementations where we are grouping about 60 to 70 million concurrent groups on a single box. So we can twist and pivot the data to a very large scale. We don't have to worry about how granular or how the various analytics get. Really, the only time you hit a bottleneck is if I'm looking at, say, I want to calculate metrics for every individual user. We can do that fairly easily in Stream Insight, but is that really useful data? If I'm reacting to it automatically, if I'm thinking about search experience optimization or ad placement, great. If I'm putting it into a report with 70 million rows, probably not overly useful. Based on the groups, I look at a time slice. So far we've talked about where I take the timeline and I break it up into even chunks. We're doing that for a reason. Essentially what we want to do is we want to take that large volume of noise and we want to winnow it down. We want to enrich that and get out business contextual information in quantized chunks. The interesting thing is if I do evenly non-overlapping windows in time, I can throw them into SQL and then I can sum them up. If I want daily totals or daily averages, since these windows don't overlap, I can use all the built-in relational and data processing functions I have available. In a second, when I switch over showing the live view, is we also have a real-time view, where instead of looking at even 30-second chunks, which means that I have to wait 30 seconds on the server to get new results, instead we have more of a real-time view against the same data, just a little bit of a different pivot. We ask the same KPI, the same averages, the same counts, the same sums, but instead of saying, look at 30 seconds, and then look at the next 30 seconds, and the next 30 seconds, we ask a slightly different question, which is, what has happened in the last minute, and tell me something new every second or every 5 seconds. So we get much more of a real-time view. It's not useful information to put into a database and then to do roll-ups after the fact, but it's great if you just want to see your trends and you want to reduce your processing latency. So we have the flexibility to kind of advance time and generate results in a couple of different ways. So we have a bunch of these internal these queries. So for example, we start off, we look at videos. I want to see who's viewing my videos. I group by my app and my video, and then I do a bunch of math to figure out some interesting KPIs. One of the interesting things that the Stream Insight engine can do is it's compositional, meaning that I can take the output of one query and I can flow it into another. So I can do all my roll-ups in memory so I don't have to calculate them in a relational database after the fact. For example, here's an example of a composition. I take my raw input stream, which in this case is my quality events. I group by, I want to know information about each combination of a video and an edge server. So for every video in my system, I want to see how the edge servers are responding in case I have a particular CDN node that's not behaving well. And I can correlate geography with edges after the fact. So I go through and I calculate all kinds of KPIs. But then I go, okay, but now I want to roll up just by video. I'm interested in just those video sums. So I could take the raw information, I could recalculate it again. Well, it's not very efficient. Well, instead what we're going to do is we're going to take the results from the previous query, roll them into a new one, and now we're going to pivot by just the video and put those sums together so we can cut down our processing. Essentially, every video event that comes into the system that's running live right now, we look at it 7 different ways. So we might take in 125,000 events a second, but we're effectively processing well over 1 million in terms of the different ways we look at data. So this is just a bunch of code. It's reasonably straightforward link. The first time you see it, it's pretty scary. Once you get your head wrapped around it, essentially every KPI looks exactly like this. The only things that change are which fields am I going to group on, what window of time am I interested in, how often do I produce new results, and what are the aggregates that I'm creating, my averages, my mins, my maxes, and my sums. So what this actually looks like behind the scenes, if we bring up the... So what I have running is I have an on-premise version of the Stream Insight server running on the laptop, and I'm going to kick a little bit of data at it. So I have some pre-canned data captured from PDC that I'm going to push through the system and just show you what happens on the way through. So breakpoint-based debugging does not work when you have 100,000 things happening in a given second. So Stream Insight actually has a customized debugger that's specifically designed to help you understand where do my results come from? Am I looking at data the right way? Am I calculating reasonable results? And I don't use a Mac, so this keyboard is kicking my butt.
You have it already open on the other one. You have another debug version.
Hmm? Do I have another one of those open?
Yeah, I think so.
Oh, I do. Huh, look at that. And the help from the audience saves the day. So this is the Stream Insight debugger. Basically what I'm looking at is the live Stream Insight engine. And unfortunately, I apologize, it's a little small. I'll zoom up the actual results. So what I can see is here are all the live queries that are running. So I have a bunch of things where I'm looking at viewers. So I look at viewers by application and by country and by edge and by region and by video. So every one of those video quality events, I look at 3 different ways in 30-second chunks. But I also have this little thing called real-time viewers by video, where I take the exact same query, but I use a different time window. So viewers by video says, take the stream, break it up by video, look at it in 30-second chunks. Real-time viewers says, take the stream, break it up by videos, look at it in 1-minute chunks, but a different 1-minute chunk every second. So every second, look at the last minute's worth of data and produce a result. So I get a lot more output. Most of it's just noise, but it's really great if I want that nice real-time graph and I don't want to wait an extra 30 seconds to get results. So it gets into an interesting balancing act of what's the information I need immediately in order to make good decisions? What is the information that I can wait a little bit of time for, but is useful to roll up after the fact? And in terms of generating kind of really rich BI, it makes the difference between having to process a few billion rows in order to make decisions or a few 100,000 rows of enriched, useful information. And from an IT perspective, you're not putting a lot of noise in an expensive data store. So just under the hood, if I just want to go in and actually look at, right, this is a slightly different, all right. Never mind, the demo gods are biting me. And I'm going to skip that part because I messed up some of the one of the security configurations under the hood. And since we are running a little short on time, I'll just skip ahead. But essentially, that's the metrics under the hood. We take the data, shape it with queries, put it into and flow it into an external store. So in this case, I have you can see all of the tables matching the queries. Apologies, it's a little hard to read. Essentially what happens is each one of these queries is going to generate two tables. One is going to be the list of all the events. This is a historical record. This is the thing you can pull into a data warehouse or pull into Power Pivot. But we also generate a little thing called a snapshot, which is this is the last window of data that was generated for a query. So if you do want to build a dashboard that's just looking at the most recent value, we give you a cheap way to do that. You just basically hit this table, pull everything out, rather than having to do some form of a lookup, especially if the event tables start getting into very large numbers of rows. So I can just go in and have a quick peek at, for example, this is just looking at the viewers by country. What were the results of the last window? Looking at the PDC data. And in this particular case, I can see these time windows. So in this case, between 5:15:41 and 5:16:01. So these happen to be 20-second windows. I can see that I had 2 concurrent users for a country. I have no idea which country 99 is. There's another country table. I just haven't joined it in. And I can get some metrics. So basically, I just winnow down the data. I'm not looking at noise. I'm looking at useful information.
Cool. I always love whenever the debugger breaks for whenever you're trying to debug something. It's awesome. OK, so the last piece of this is the visualizer. This implementation kind of runs on an Azure web role to basically produce OData feeds. And it's scalable. I mean, we're kind of estimating probably 40, 60 number of clients. This isn't necessarily something you just want to throw a ton of people at and say, give me a bunch of data. We're going to kind of leave that to using things like Power Pivot or other tools that are out there that can just do a better job at crunching data. The implementation that we built, though, it does some interesting stuff. It does live and archive rendering. It will also do multi-y-axis modeling, which is very important once I show you some of the questions that we're trying to ask. And then there's this whole concept of dynamic stepping, so I can actually change the step and view of the window. And we do some smart segment caching, so as data is coming down to the visualizer, it's snappy. You're not waiting for data, because if you're trying to watch something in real time, well, you want to make sure that it's rendering in real time. So let me refresh this and go into full screen mode here. And I'm going to go ahead and pull back on my timeline. Oops, I'm giving you a demo and you can't even see it.
Looks really great from up here.
Yeah. OK, cool. All right, so here we go. We're actually at live right now. Let me go back and click. And what I'm doing here is showing this concept of we're basically pulling across the timeline and we're rendering right here. We're rendering concurrent users. This is actually a snapshot of some data from the Mix keynote yesterday. And you can kind of see, kind of keep going back in time, keep sliding. And then this is data from yesterday as we're ramping up into the keynote. And then we start ramping back down as things are ending. So this is the real-time stepping, so I can start to get more and more fine-grained, so I can change the x-axis in terms of its granularity. Sometimes you may want to look at things usually in say 10 or 20-minute windows, and sometimes you want to look at, well, what just happened in that last 1-minute window because it was really important. Maybe we got a spike. So this is all rendering in real time, where I can go back to live, and it'll just sit there and step as new data comes in. But I'm going to go back here, and we're going to have some fun. So this is my concurrent users. I can do things like, well, show me by country. So it's going to go back and pull down all that data and visualize it by country and say, well, that's pretty cool. And then maybe I just want to drill in the United States. Well, OK, that's nice. Or I can kind of pop this back off. Or I can drill in by video to see what I had. We had a couple different videos that we were going on. We were also testing with the CES keynote. There's my Big Buck Bunny demo that we were talking about. So that's cool. But what this tool is really, really helpful at doing is I'm going to take average buffering and drop it onto my other y-axis. And it's going to go out and start pulling down all the buffering information against those concurrent users. So there's a direct correlation between buffering. So as buffering increases, we're going to notice some type of drop-off. So I now have the ability to model 2 different data points in real time on the y-axis, which is really, really helpful. Or I can kind of pop this off and then look at average bit rate, because I want to see what type of quality people are getting. So it looks like most people are watching anywhere between, and this is something we're actually investigating. This is what happened yesterday. We don't know why this happened. Was most people, whenever they were watching the keynote, were at around 1.5 megabit, which is the highest bit rate for the window. But whenever we switched to channel 9 in the afternoon, looks like everyone went to full screen mode, because then we were up at 2 megabits or something like that. We're still trying to figure out what happened. But this is, you can actually do this type of analysis because you have this type of data. I've also done some stuff, like if you go by country, I can then go in and pull out, well, these are the top 5, but there's actually a whole bunch of other ones that aren't displayed. So maybe I want to remove Germany and Japan and see how Sweden's doing against the mix. And then you can kind of see Sweden drop down in the bottom. So this is another cool part of this tool, is being able to like quickly drill in and find the pieces that you want. The other bottom piece of this, which is something that we're extending, is being able to look at real-time KPIs on things that are happening in real time. So Mark talked about we have these history windows, but then we also have these snapshots about what happened in the last time window. And this is what we do whenever we're running these events. We're looking at concurrent users. We're looking at average buffering. And as soon as we see those numbers going the wrong way, then we're off to the races starting to look at the analysis of the data. Really, really helpful tool. So these are some of the real-world samples. We're looking at, as buffering increases, duration is going to start to go down, which is a bad thing. You're going to be losing users. We have concurrent users against average buffering. So we talked about these visualizer features. The other piece to this is, if I go back over to E. Just close him down. If I go back to Power Pivot, I can also suck down all that data and do interesting things like this. So now I'm in Excel and I'm looking at that same exact data. I'm looking at concurrent viewers, but I can go ahead and filter through Power Pivot. I've actually sucked down hundreds of thousands of rows into Excel, and Power Pivot understands how to process that amount of data, and I can do my own kind of real-time filtering inside of Excel and graphing. So it's kind of pick the hammer that you want to use, or the tool that you want to use in order to solve the problem. This is a great kind of post-BI tool, versus the visualizer tool is great for real-time in-flight analysis. Okay. So as we wrap up, I want to talk a little bit about like modeling and kind of how this thing is going to look whenever we release it. So we're talking about this implementation. We have several edge nodes and then one stream inside implementation. You can do roughly around 100,000 clients. You can throw 100,000 clients at this with the log template model that we've provided around video and video quality, and keep up in near real time. At any given point, like if you start to get some like really big swing and deviation in your spread, like you have everyone come into your experience at the exact same time, which is typically not what happens, it's going to take around 7 to 10 seconds for the system to recover. So you're going to see this spike and then this nice little blend off as the system starts to catch up with its buffering system between the client and the server, and then our hopping windows inside of, or our windowing inside of Stream Insight. So that's the type of implementation that we're targeting right now. If you wanted to go build this today, there's some interesting economics of this. Currently, we do not support SQL Server in VM roles on top of Azure. This is something that the SQL team is actively working on right now. However, if you did have access to SQL licenses, you could go set up VM roles and do exactly what we're doing, and you can make the system work, but you then kind of get into a supportability mode. We also have this concept of licensing. So the implementation that we were looking at is an enterprise implementation. So if you have an existing SQL Server enterprise license, this is kind of what it would cost to run this per day. if you're thinking about, well, how much is this going to go cost me if I go buy the enterprise version. It also runs on a standard version of SQL Server, but it has less capacity to process events per second. So this is kind of targeting if you want to hit 100,000 users, this is the type of implementation that you would buy. So we started doing the math for you too, like, well, how much does it actually cost to run a Red Bull? So if you wanted to do this for a day, this is what it would cost you to do. There's also some work going on to just understand how can we provide more turnkey services for Stream Insight in the cloud, as we're thinking about our licensing models for SQL Server on the cloud. And I would look for more information from us over the next couple of months, but this is kind of where things stand today. You could take this exact same implementation and also run it on-premise if you wanted to. Rack up some servers, wrap up another SQL Server, and you're off to the races. So on the horizon, what's happening? We're working on general availability of this service source. So you can go ahead and start actually getting your hands on what we've built. We also have a load testing harness, something that we call the pane. We have the ability to spin up hundreds of thousands of users on Azure to go ahead and just pound the heck out of your service in order to see what's happening. So we're also going to publish that code. And then we're also working on implementation for clients to port to HTML5, iOS, and potentially Flash, because we know that Silverlight's not the only client media rendering technology out there. I'm going to come back to that in a second. So next steps, kind of things to think about is go back and think about, like, how could you actually extend your existing workflows to take advantage of these real-time KPIs, and then what problems are most critical to solve. We actually started out with about 35 queries back in the day whenever we started, and we narrowed it down to 14 because we realized that 35 isn't what we needed. We needed these 14, and we needed them to work really well. You may only need 3. In order to get there, go download a SMF so you can start getting this understanding of logging and remoting. And then download Stream Insight. You can download it for free, run it on the SQL Server Eval Edition, start getting your hands wet in terms of how these systems work. Between now and whenever we release this reference implementation, we are taking on some partners. So you can contact one of the folks on this slide here. And we're kind of looking at, if you have a consumer oriented scenario, are you focused on the cloud, and are you really looking at solving some business value or driving some business value? That's kind of like how we're looking at what types of customers we want to work with. So with that said, I do want to give a special thanks again to Vertigo and to SoftSource for their help with this. Vertigo on the SMF side and SoftSource on the visualization side. Without great partners, we wouldn't be able to get this work done. So with that, thanks to Mark, and also Jeremy Kath on my team, who's been also running this project. We'll take some questions. So.